are in listen-only mode.
Good afternoon, everyone, and welcome to the Society of Wetland Scientists March webinar. My name is Ariana Sutton-Greer, and I am hosting the webinar today. I'm research faculty at the University of Maryland and the Ecosystem Science Advisor for the National Ocean Service. I am also on SWS's webinar committee, and I'm especially excited about today's topic with my invited guests, Steve Crooks and Tiffany Troxler, when we'll be discussing the challenges and successes of incorporating coastal wetlands into the U.S. inventory of greenhouse gas emissions and sinks. We have a great turnout today, and at the end of today's webinar, I will announce next month's webinar info as well. Just for all of you listening, the format of today's webinar will be about 40 to 45 minutes of presentation by our speakers, and then about 15 minutes of questions from all of you afterwards. Before we get going, since I know we have some folks who may be new to Society of Wetland Scientists, I just want to introduce a little bit about the Society. So the mission of the Society of Wetland Scientists is to promote understanding, conservation, protection, restoration, science-based management, and sustainability of wetlands. The SWS was founded in 1980 and now has more than 3,000 members worldwide. The Society promotes wetland education, conservation, and restoration globally. Member benefits include this complimentary webinar, monthly webinar series. There are quarterly free ones open to the public, so the next one of those will be in June, but members get to attend all of the webinars for free, as well as access to the journal Wetlands, Wetland Science and Practice, and many more benefits. So please visit our website. You can see the website on the slide there to learn more about member benefits if you are interested. We have just a couple of housekeeping items today to make sure that you guys all know how to access the system. So you've got an attendee control panel where you can control the audio for the webinar, and you can use your telephone or your mic and speakers. At any time during the presentation, you can type your questions into that questions pane, and I'll be collecting those questions throughout the talk, and then we'll ask the speakers at the end. Your phone lines, just so you know, will be on mute in order to cut out background noises, so that's why we ask you to do questions in the question pane. And then there'll be a chance to do an evaluation survey at the very end. Hopefully many of you will participate in that, since that helps us plan future events. If you'd like a copy of today's slides, please find a PDF copy in the handout section of the control pane. And if you are tweeting about today's webinar, please use the hashtag SWSwebinar. Okay, so with those logistics out of the way, let me get on to introducing our two speakers. So it's my pleasure to welcome Dr. Steve Crooks and Dr. Tiffany Troxler today. Steve is a founder and principal at Silvestrum Climate Associates, working on integrated climate adaptation and mitigation in coastal areas. He is also a wetland restoration practitioner and a founder of the International Blue Carbon Initiative. Steve was a national delegate to the Paris Climate Negotiations and a lead author of the IPCC Wetland Supplement, providing guidance on inclusion of coastal wetlands in national greenhouse gas inventory. Tiffany directs the Sea Level Solutions Center at Florida International University, a state university center that focuses on advancing knowledge, decision-making, and actions toward mitigating the causes and adapting to the effects of sea level rise. She is a research scientist with expertise in coastal and wetland ecosystem science. Some of her projects include collaborative research that examines the effects of saltwater inundation on Everglades coastal wetlands, monitoring management actions associated with Everglades restoration, and advancing interdisciplinary urban solutions to sea level rise. She has authored over 30 peer-reviewed articles and book chapters, and was co-editor and contributing author on 2 IPCC methodological reports published in 2014 that guide greenhouse gas emissions estimation associated with land use and land use change in wetlands. So we have some of the world's experts here today to discuss this topic with you. I'm so excited for this webinar. And with that, I welcome both of you, and I turn it over to you, Steve and Tiffany.
Great. Thank you very much, Ariana. And if I can move the slide, there we go. So thank you. Tiffany and I would like to tell you a little bit today about the inclusion of coastal wetlands in the U.S. Greenhouse gas accounts and the report of GHG emissions and sinks. We are representing here a much broader team, and we're very happy to represent them. I'd particularly like to call out Tom Worth at the EPA, who's been a strong supporter of the inclusion of wetlands, coastal wetlands, within the inventory. Also Nate Harold from NOAA, who we've been calling upon his skills in spatial analysis using the Coastal Change Adaptation Analysis Program, and also Blanca Bernal from the Smithsonian Environmental Research Center, who has been helping us with the development of the country-specific emissions factors. So what I'd like to run through is a little bit of the background of the inclusion of wetlands within the inventory, why this came about, and then Tiffany will tell us about the IPCC process and the process that the US goes through in terms of developing the inventory and the reporting process. And then we'll come back to what we've actually done over the last couple of years, what's included in terms of coastal wetlands, and then where we see things hopefully going in the next few years in terms of further developments. We'd especially like to thank the officers and services of NOAA who have supported very strongly the development of this process and has allowed the team to support the EPA with inclusion of coastal wetlands. The team of, let's say, sled dogs who have been pulling together the analysis have been very much supported by a team of the US Coastal Wetlands Carbon Working Group, an ad hoc working group who have come together and donated their time to help us with the development of the science and also make sure and review and QC the analysis as we've been moving forward and the thought processes which has been developing. In parallel to this, a project funded by the USGS and under the NASA carbon monitoring program called the Blue Carbon Monitoring System has been working in parallel, and many of the PIs have been part of the US Coastal Wetlands Working Group, and this project here has been looking at combining spatial analysis along with developing carbon stock and stock change data for the US Cornice coastline. And in future iterations, the development of emission factors, stocks and stocks changes, which are going to be coming out of this project this year, we intend and hope to be including in future iterations. So stay tuned for the inclusion of this new science which is coming online. So what's the background? Well, over the last 20 years or so, there's been an increasing move to include the biosphere within our climate change mitigation strategies at the national and international level. This began primarily with forests, and then over the last decade to 15 years, the recognition and the steps towards including soils, the world soils component within the climate mitigation strategies has been becoming more prevalent. Now, over the last 5 to 7 years, the coastal community has been pointing out, well, you know, it's not just terrestrial soils, we should actually be moving down slope and including the biomass and the soils of coastal ecosystems, mangroves, tidal marshes, and seagrasses. Part of what changed the discussion was around about 5 years ago, the recognition that not only do coastal wetlands gradually accumulate carbon through time through carbon sequestration, a process which continues with rising sea level and the burial of carbon within soils, but really that from a climate change mitigation perspective over coming decades, we are really actually releasing hundreds of thousands of years worth of carbon back into the atmosphere. A synthesis that was done and provided in 2012 here sort of estimates sort of first sort of scoping level scale that roughly potentially 450 million tons of CO2 are being released back to the atmosphere directly or through the legacy effects of exposed and drained organic soils. Now our error bars are quite wide. It could be as low as 150 million tons. It could be as high as a gigaton of CO2 being released each year. And so part of the process to understand this is a requirement to have better understanding at the national level of what our emissions and sinks are. By good fortune, the IPCC, were in the process of scoping out additional guidance for the inclusion of wetlands within their greenhouse gas accounting procedures. They provide procedures already for the accounting for forestry, cropland, etc., but wetlands were largely missing until this point. Our good fortune was that the release of this study helped to encourage the consideration of the inclusion of coastal wetlands within this broader review. And this report was published in 2013. And I'll pass over to Tiffany.
Thanks, Steve. Oh. Are you advancing them for me, Ariana, or did I do that? Oh, there we go. Okay, great.
I didn't touch it.
Okay, super, thanks. Thanks, Steve. That was a great introduction. So now we'll just go into a little bit about the United Nations Framework Convention on Climate Change, which is primarily focused around international cooperation toward action to limit the emission of greenhouse gases into the atmosphere. And the primary directive is that with the capacity to reduce emissions of greenhouse gases, we can achieve a stabilization in greenhouse gas concentrations in order to avoid catastrophic interference with the climate system. And that international treaty was put forth the framework as a framework for international cooperation in 1992. In 1995, countries started working together in greater earnesty to launch negotiations toward strengthening that global response. And from that came the Kyoto Protocol, which was put forth in 1997, and that we have 197 parties to the convention and 192 parties to the Kyoto Protocol. And as most of you are likely aware, the 2015 Paris Agreement is the most current evolution of the global response to climate change. And that Paris Agreement charts a new course for accelerating and intensifying actions and investment toward a low-carbon future. And one significant component of that Paris Agreement is coming together around limiting global temperature to well below 2 degrees Celsius above pre-industrial levels, and even to undertake efforts to further make reductions toward 1.5 degrees Celsius below pre-industrial levels. And so the IPCC's Task Force on National Greenhouse Gas Inventories was created in order to develop the methodologies that countries could follow in order to make those actions toward reducing greenhouse gas emissions. Essentially, the premise is you can't reduce it unless you can measure it. So it's an effort to provide those guidelines in order to reduce greenhouse gas emissions for countries and to contribute to national mitigation and emission reduction plans. So the IPCC guidelines are developed for and intended to be used by all countries to the convention. They provide default data and methods. They provide guidelines that allow countries to try to focus the most resources in areas where they can achieve the greatest reductions in emissions or improvements in sinks in greenhouse gases. The methodologies provide standardized methods, QA/QC guidance to ensure that countries are developing their inventories with the greatest transparency, accuracy, completeness, consistency, and comparability. And it's set up so that countries can use more sophisticated methods if they choose to. And essentially the methodologies and guidelines came out of the idea of good practice, which was put forward by Jim Penman in the mid-90s. And the premise is that good practice allows for a reduction in uncertainties around greenhouse gas emissions as far as practicable, and then also puts forth those guidelines for quality assurance, consistency, comparability, transparency for increased credibility of the emission estimates that countries are developing. And again, the credibility in this context is very well defined as part of the guidelines, and that information is used as part of training that the IPCC Task Force on Greenhouse Gas Inventories also conducts for countries, commonly applied at the regional level to help build capacity for countries to undertake their own greenhouse gas estimations. And so the basic method that's put forth, it's essentially countries are charged with developing activity data, and these activity data can be national or international statistics. And those activity data are applied to emission factors to come up with emission estimates. And countries are provided guidance on how to develop estimates at 3 methodological tiers. So the first tier is essentially considered a first-order approximation, and guidelines provide those default values and methodologies for those default values to be applied so that countries are mostly charged with developing the activity data that are used to develop those estimates. And then a Tier 2 approach, in this case it's where countries are developing their nationally nationally specific or country-specific emission emission factors, and then those are applied similarly as the Tier 1 with national statistics developed by countries. And then a Tier 3 approach, which is anticipated to be the most resource intensive, but reducing uncertainties even further, is oftentimes countries will apply modeling techniques that are developed with the capacity within those countries. And so the guidelines are not limited to what we'll be talking about mostly today. Those guidelines are comprehensive, and they address sectors which include energy, industrial processes, waste, and in addition to agriculture, forestry, and other land use, which is the sector where we address coastal wetlands. And the guidelines also have developed and evolved over time, beginning with guidelines that were developed in 1995 up until the most recent supplemental guidance, which was published in 2014. So in the sector of agricultural, forestry, and other land use, lands are classified in 6 different categories. These are forest land, cropland, grasslands, settlements, wetlands, and other lands. And these were largely derived for estimating greenhouse gas emissions and removals on terrestrial lands. And understanding that there was a large gap in the 2006 IPCC guidelines, specifically with regard to wetlands, the SubSta put forth a request to the IPCC to develop supplementary guidelines for wetlands. And one primary focus within that new supplementary guidance was on coastal wetlands. And the coastal wetlands guidance, and much like the 2006 IPCC guidelines, is these are developed to be applied by all countries globally. So the process is to identify what, bringing together a suite of experts to identify what are the largest emissions and removals that we are aware of and that we have data to support that would justify inclusion in the methodological guidelines. So it's a global approach to the development of guidance around emissions and removals associated with coastal wetlands. And so those emissions and removals that were identified included CO2 emissions from certain types of management activities, nitrous oxide emissions associated with aquaculture use, and then methane emissions from rewetting and creation of coastal wetlands. And this table illustrates some of the more specific activities that were identified as part of the development of that wetland guidance, including activities relevant to CO2 emissions and removals. This included forest management, extraction activities, including excavation associated with coastal development, construction of aquaculture and salt production facilities, drainage, rewetting, and revegetation, and then those activities that are relevant to methane and nitrous oxide emissions, aquaculture use, and rewetting, revegetation, and creation of coastal wetlands. And
so thank you, Tiff.
Yeah.
So in the US, we're in a situation where fairly strong regulation was passed 40 years ago, which limited the amount of conversion of coastal wetlands to other land uses, as is seen in many other parts of the world still continuing. And so when we look at the potential emissions and also the removals that might be occurring within the coastal land area, they break down into the following. Emissions and removals of CO2 and methane on intact and restoring wetlands. We do have an active program of restoration, of course, within the US. Drainage and excavation activities within the US. There is still conversion of coastal wetlands, even though we have regulation, and we shall discuss what those emissions are. Excavation is actually a difficult thing to try and get values on in terms of potential emissions, and so that might be an area of potential improvement in the future. And then the next parameter is actually the conversion of wetlands to open water. We consider this a wetlands to wetlands conversion, but with the erosion of coastal wetlands, which is primarily occurring within the Mississippi Delta, which is largely due to how we've managed sediment supply and other activities within the Mississippi Delta, we do see a release of CO2 back to the atmosphere. To get at this number, we actually use the excavation procedures where we assume a 1 meter depth of impacted soil, and the carbon from that soil is released in subsequent years. Another activity which is ongoing, for which we have very little data and is not included in the inventory at the moment, is the impacts of forestry actions on wetland soils within the coastal land area. This is a substantial practice within the coastal land area, but the implications for the soils is just not known. And one other factor is the methane emissions from impounded waters, where barriers have been built, roads and other features, which have led to a reduction in salinity. An increase in methane has resulted from that. And work is ongoing to try and estimate what those emissions would be associated with those impoundments. Finally, aquaculture. The release of nitrous oxide associated with the food supply provided to maintain aquaculture is in addition one potential emission that takes place. So how do we do this? we applied as our basis for analysis the NOAA Coastal Change Analysis Program, NOAA CCAP. It's a spatial data set that is updated every 5 years since 1996, and so the last iteration was in 2010, and there's a current iteration under analysis based upon 2015 data. It's based upon Landsat data with a 30-meter pixel, and it's a QC data set, and so we have a good understanding of the accuracy of reporting in terms of various land uses. And there are a number of categories that the data set describes, which includes various coastal wetlands, which I'll come to, as well as land use practices, agriculture, settlement, etc., that are found in coastal land areas. The approach that we took was to clip this data set and define our coastal land area based upon the tides. So the guidance within the IPCC is that the most landward extent is the reach of the highest tides, and so we use the NOAA data sets for tides associated also with LiDAR data to map that contour and provide the upper end of our boundary. The lower end of our boundary is defined by the extent of the mapped land representation of the lower 48. That extends to the outer reaches of coastal tidal wetlands, and unfortunately this time does not extend as far as seagrasses. So our analysis right now only includes tidal wetlands. Our process was our requirement was to quantify land use change between 1990 and 2015 and the impacts on both mineral and organic soils. As our data set extended between 1996 to 2010, this required interpolation between those data epochs, but also an extrapolation out to 1990 and up to 2015. Once we have the mapped and quantified land use change upon these soils, we then take an ascribed CO2 and methane emissions factor and apply that with the land use data. We could have applied the IPCC default values, which are provided within the Wetland Supplement, but with the help of the Smithsonian Environmental Research Center, we developed our own country-specific reference stocks and stock change, which was broken down to the climate regions of the US. So we have 4 subsets within the US to which this data was applied. We then calculated annual emissions and our removals for wetlands remaining wetlands, wetlands converted to open water as a subset of wetlands remaining wetlands, and then other lands converted to wetlands. I'll also report back here on the conversion of wetlands to other lands, but within the inventory that data is already included under the appropriate land use sector, agriculture, croplands or grasslands as such. But I'll provide the information here for your interest. And this is what the extent of the coastal land area is. We have representative examples here from San Francisco, around New Orleans and in the Chesapeake Bay area. And you see that the coastal land area extends, for instance, around San Francisco as far in as the inner part of the Sacramento Delta, which of course is mostly agricultural land right now. And when we zoom in, we can see how the CCAP data represents this land area. The pinks are various forms of wetlands. Blue is the mapping of coastal waters, and the browns and the yellows agricultural land or grasslands. Now, when we break down the data, what we find is that a large part, 78% of the area, is recognized as water. Now, this in itself, under definitions such as Ramsar, would be recognized as a wetland. But in terms of the greenhouse gas accounting, we are interested in the emissions or the reductions, removals provided by vegetated coastal wetlands. So if we remove from the analysis the extent of water, we find that 87% of the area is represented by wetlands, 6% by agriculture, 3% by development, but yet also we have 1% of upland forest which is existing at or below tidal elevations, along with 1% grasslands and some bare ground and upland scrub shrub. Looking at the same data set but now in hectares instead of square miles, and also breaking out the data in terms of organic and mineral soils, we can see that roughly 4 million hectares of that land is represented either by palustrine or estuarine forest, scrub shrub, or emergent wetlands. In terms of the inventory, scrub shrub is classified along with either the wetlands or grasslands category, and that reflects that there's a separation from forestry based upon the height of the biomass. And as we look at the data, if we were to apply the emissions factors for organic soils, drained organic soils, to developed land, cultivated land, grasslands, and forest land, we would estimate that approximately 5 million tons of CO2 are being released each year. Now, the assumption being that until shown otherwise by new data, that those emissions would be continuing. The new data, for instance, would demonstrate that the stock has been emitted or the management practice has changed such that the soils are no longer wet. But there are still potentially an ongoing emission of around about 5 million tons from these land areas. As I mentioned earlier, these emissions, at least for the cultivated lands, grasslands, and forest lands, should be recognized under other parts of the inventory. Developed lands or settlements, as it's recognized in the inventory, are not yet fully developed, and so emissions from that sector have yet to be accounted for. Impounded waters, we estimate at a first level to be of the order of 1 to 3 million tons of CO2 each year. The analysis for this is in its early phase. We have relatively good numbers, we feel, for the East Coast and getting into the Gulf Coast, but have yet to do the West Coast. We have not yet developed annual change for these values, and as such we've not included within the inventory at this stage these values, but look to potential future improvements down the line. Now, if we look at the emissions and removals on soils within the coastal wetlands themselves, approximately 16 million tons of CO2 are sequestered by these coastal wetlands. It's broken down almost half into palustrine systems, so non-tidal, or dominantly non-tidal, though this does include tidal freshwater marshes. And using the IPCC approaches and also using a simplifying assumption, we've made the assumption that estuarine wetlands are non-methane emitting, whereas palustrine wetlands are methane emitting systems. Now, this is something which the science can be improved upon in the future, but this is the best that we could do in terms of developing the inventory at this stage. And using that assumption, we find that palustrine wetlands are emitting approximately 8 million tons in CO2 equivalents of methane each year. And so that brings down the net carbon sequestration from these systems, the net removals, to around about 8 million tons of CO2 equivalents each year. So that's within wetlands, remaining wetlands. What about land conversion? Emissions of wetlands converted to open water. This is a process which is occurring largely within the Mississippi Delta, more than 90% of emissions from this process occurring there. It's a process which has been occurring through time since the 1930s and has been gradually declining, though is anticipated to increase with sea level rise into the future. Our estimates of emissions, which are based upon averages across 5-year epochs, are that somewhere between roughly 1 million to 7 million tons of CO2 are released each year from erosion of coastal wetlands. That number is influenced by the hurricanes which occurred in 2006, which led to an uptick in potential emissions. Our understanding here is based upon a limited understanding of the depth to which these soils are eroded. And so, as I'll mention later on, this is an area of future improvement. What was surprising to, at least to me, was the scale of the emissions that are still occurring from drained coastal wetlands around the country. And we found that over the last 20 years, somewhere between 0.7 and 1.92 million tons of CO2 are being released as wetlands are converted to some form of drained condition, be it grasslands, cropland, or settlement. Again, that's using fairly high-level scoping assumptions about the depth of soil impacted, to assume depth of 1 meter. But again, this seems to be a reasonable approach to assessing these values. Also interesting is the emissions removals story associated with wetlands restoration as identified by the occurrence of vegetated wetlands around the country. Actually, when we think about this wetlands restoration, it also includes areas in the Atchafalaya Delta where with reintroduction of sediment supply, we're seeing a building of new delta and the revegetation of those formed mudflats. And here it's about 0.02 million tons of CO2 each year. So clearly emissions from drainage are greatly exceeding the amount of CO2 which is being sequestered each year through restoration and new delta formation. So stepping back from a moment to look at the management context of this, coastal wetlands sequester net around about 8 million tons of CO2 each year. Drainage from coastal wetlands represents 0.7 to 1.9 million tons of CO2 emissions each year. Restoration of wetlands on drained organic soils, assuming non-developed land, could potentially avoid emissions of 4 million tons of CO2 each year. Restoring tidal connections to the potentially hundreds of small-scale impounded waters would avoid emissions of 1 to 3 million tons of CO2 equivalents each year. And if there was something that could be done, such as reintroduction of sediment supply to the Mississippi Delta, the amount of erosion could be reduced, leading to a reduction in the number, leading to a reduction in the emissions which are taking place, as we've mentioned, between 1 to 7 million tons of CO2 each year. And the relatively small number of emission removals associated with restoration of 0.02, it should be recognized that when they occur on organic soils or when they occur through reconnecting impounded waters are additional to those emissions reductions associated with those other activities. So back to the inventory. What have our challenges been? Well, one particular challenge, as we've come to recognize as we've been working through this process for the first time, is the challenge of including the spatial data set of the NOAA CCAP with data sets developed under the USDA for the Natural Resource Inventory and with the Forestry Inventory Analysis under the Forestry Service, which are primarily survey and plot-based data sets supported by spatial data. And so we've been working through the process with other team members to try and bring together this new data set with these established data sets. That has been a challenge and continues to be a challenge and is something that we're working on. Pardon me. Calculating emissions, when land is converted from one form to another, emissions are tracked for a 20-year period before it becomes considered to be part of the new land use category, and in which case it becomes accounted for under that. Of course, within a coastal wetlands conversion, they may go through several stages as part of this process. and the procedures provided by the IPCC do not currently recognize that kind of multiple conversion. And so we have run into challenges in developing the accounting process to recognize that. That's not a big impact in terms of the accounting, but is a procedural impact that we're having to address as we move forward. Another challenge has been the interpolation and extrapolation of emissions estimates using the CCAP data based upon 4 data points representing the 4 epochs that we have, particularly reflecting that one of those data points was heavily driven by 2 hurricanes in 2006. And so this data set, this analysis will be improved when the 2015 data set comes online in a couple of years. We have also been limited with additional data which the Society of Wetland Scientists could potentially help us with, understanding the extent and changes in seagrass. There's one particular data set which prevented us from including seagrass in this analysis. Our data set for emissions stocks, stock change, and methane fluxes for palustrine wetlands was not large. And so we're going to continue to look at the literature, but additional data on these wetland areas would be helpful to the process. There is very little data indeed, next to none, on the impacts of forestry procedures on coastal wetland soils. That remains something that's not in the inventory. That could be improved on down the line. Methane emissions from impounded waters. We have very few emissions factors and very few data sets describing emissions from impounded waters, and this is something that could be improved upon. There are research activities taking place, but more would be welcomed. And improved quantification on the fate and the extent of eroded carbon from eroded wetlands around the US. What are unplanned improvements? Right now, the analysis has been limited to impacts to changes in stock associated with wetland soils. The project under the NASA carbon monitoring system will provide within the next year an estimate of biomass change. Well, they'll provide an estimate of carbon within biomass for coastal wetlands, which we can use then to estimate changes in biomass carbon stock with land use change. So that will be coming online within the next year or two. We are continuing to refine our data set of soil carbon stocks and soil carbon stock change, and we continue to integrate the NOAA CCAP with the NRI and FIA data sets. Potentially with future work, we would like to include seagrass meadows within the inventory, but we are, as I mentioned, data limited in this regard. We hope to include improved emissions factors and reference stocks for palustrine wetlands. We hope to include emissions and changes in emissions associated with management activities on impounded waters. Potentially further down the line, improved understanding of forestry activities on wetland soils, though this will largely fall under the forestry category, forest lands category. And inclusion down the line, not by our group, but the analysis so far only focuses on wetlands within the coastal land area, and potentially other wetlands upslope from those will be included in inventory potentially down the line. And with that, I'll pause here and open up to questions or comments. Thank you very much.
Great, thank you so much, Steve and Tiffany. That was a great overview. And right now, people, if you want to go ahead, all of you listeners, and write in questions, I will be looking for those so that I can ask Steve and Tiffany. But I have a couple already lined up and ready to go here. So first of all, Steve and Tiffany, what are the next steps for the U.S. greenhouse gas inventory with regard to coastal wetlands? What happens now? You guys still there?
Sorry, still on mute there. So the next stage for the inventory, right now that where we are, is that a full draft of the report, including coastal wetlands, is out to public review. That public review stage is due to be closed tomorrow. And the full version of the report, hopefully including coastal wetlands, will be submitted to the UNFCCC in April. So at that time, we'll find out how other countries have been doing, and the US will will continue a discussion with UNFCCC in terms of lessons learned. We are hopeful that the process of including wetlands will continue in future years, and we'll be able to include the data which is coming out of the carbon monitoring system project in terms of refining our data sets and our emissions factors as we move forward. One additional good piece of news is that the National Science Foundation has supported the Smithsonian Environmental Research Center and partners with funding to build a data archive, so that as research comes online, it can be imported into this data archive, which will help us develop reference stocks for biomass, for soils, and for stock change as research comes online.
Great, thank you, Steve. Okay, so some questions from our participants today. So one of them I think is about forest soils and the comparison between forest and wetland soils. So the question is, how uniformly is forest soil included in forest carbon estimates in the scientific literature? And depending on the answer to that, how does that pose a challenge to getting accurate comparisons when you're moving from terrestrial forest to coastal wetlands in both the literature and scientific discourse?
Yes, good question. As I understand it, under the forestry category, they're in the process of updating their stock data to a reference depth of 1 meter. And if there's anyone listening in that would like to correct that, just let me know. But that's my understanding as I recall. And so that would make comparisons with the coastal wetlands data set relatively good, because we also use a reference depth of 1 meter. The amount of spatial coverage under the FIA in coastal wetlands and coastal wetlands areas is something, but it's not a substantial data set. And in the particular aspect in terms of forestry activity on coastal wetlands, I think that's an area where we have very little data in terms of carbon stock change. So I think this is an area where future research would be helpful. As we're just starting this process of integrating with the forestry analysis and also with analysis on croplands, I think we're going to get into looking more closely at how the coastal wetlands data set and the forest lands data set align. And it could well be the case that we don't have full alignment at this stage, and we'll be working through that process hopefully over the next couple of years.
Great, thank you. So I've got a couple of questions that are a little bit more about the details of the inventory process. One is simply, is there a good book on the history of the IPCC and the UNFCCC and that sort of process? And then the other question related to that is, for all the habitat types in the inventory, is carbon estimated or measured? And I think you guys can easily answer that one. And then, are those methods for doing so, are they available somewhere? Can we point our listeners to where they could find that information?
Thanks, Ariana. This is so great question. To my knowledge, I can recall asking one of my dear colleagues to write the very book that the participant had asked about. And to my knowledge, I do not know of a book that provides an overview for that. But we do have, actually, and Ariana as a contributing author to this, a new book that will be coming out specifically on blue carbon, and there will be some coverage in that book on the international policy around the UNFCCC and other policy issues regarding blue carbon specifically, and I would expect there'll be some coverage to the point that the participant had asked. But that would be a great, if anyone within our SWS community does have a suggestion for a book as an overview of the UNFCCC, and that would be a great thing to provide to our listeners. The second question, it was whether carbon is measured, or what was that, Ariana?
Yeah, so it's for each habitat type. Is carbon estimated or measured, and are there methods available that the listeners could go look at?
Well, Steve and the International Carbon Working Group put out also a methodology report on more of the specifics of making those types of measurements. Steve, if you want to talk about that at all?
Yeah, sure thing. So if the resource can be found, that there's a guide to soil carbon quantification and field analysis and laboratory analysis, and it's under the bluecarboninitiative.org, and it can be downloaded for free from that resource. Again, that's thebluecarboninitiative.org, and all the procedures are provided in there. And in terms of the data set that we've used, we've developed country-specific data that is based upon the published literature for reference carbon stocks and carbon stock change. And under the NASA USGS project, we now have a data set of we have a high resolution data set that includes cores, around about 1,900 cores from around the continental US. So that's a pretty representative data set that we have right there. I would mention the data set is strong on tidal wetlands and soil carbon accumulation. The data set needs expanding. We need people working more in areas where we have degraded wetlands and we have wetlands converted to other lands, particularly having an estimate of the stock change and emissions associated in the years immediately following wetland conversion. And so that is an area where we'd like to see, we request more work be developed. And also the data set, as I mentioned, for palustrine wetlands is relatively thin. And so we used a small data set that was available, which fell within the range for soil carbon change for tidal wetlands, and we applied that, and we applied the Tier 1 default value for methane emissions to those palustrine wetlands. And that data set, I feel, could be improved moving forward.
Great, thank you. So one participant actually had a suggestion that I just want to mention, which is that the EPA Chesapeake Bay program has seagrass data going back to the 1980s, collected mostly by Bob Orth at VIMS. And so the participant was suggesting this might be a good beta test of maybe a place to find data to start incorporating seagrasses in the future. So that's a great suggestion. And then another question, which is, why don't we have better estimates of global tidal marsh extent? For example, on the Blue Carbon Initiative website, the range is given as 2.2 to 40 million. So why is that range so big? Why don't we have better estimates?
That is a very good question. And interestingly, as we've been going through this process, we're also looking at the status of the blue carbon stocks and stock change for 14 countries across East Asia, from China through to West Papua. And what is interesting to find there is we do not have a good understanding of the extent of tidal marshes in that region either. There's some work that has been done by the Chinese, but largely tidal marsh mapping is insufficient globally. And one of the things that we found with the USGS and NASA project is that it is possible to develop that tidal wetland map. You know, it is being done using remote sense data for the continental US. There have been researchers which have done similar work in Argentina and southern Brazil, but as of today, we do not have a correlated data set for tidal marshes, and so I would recommend that somebody put together a research proposal to help us fill this data gap, because it is sorely needed. A similar assessment is required also for seagrasses, but it's a different problem there, because with it being submarine, the remote sensing approaches are more challenging. But in terms of the intertidal wetlands, there is not a methodological or a technical reason why we do not have this data set at this time.
Great. Okay, so here's one that I'm guessing is on a lot of people's minds right now, which is, how does the change in the administration potentially impact the outlook for blue carbon inclusion in national and international carbon policies?
Well, that's what we are also looking forward to finding out. I think at the international level, outside of the US, everything will continue along. We have yet to see how things develop within the US over the next few years.
That's a very good, safe response, Steve. Thank you. But no, a very good response. We're really just not sure.
Yeah.
So there's a question about why are mangroves, why do they have such high levels of carbon sequestration?
Interesting. They do apparently, from the existing data sets, have slightly higher carbon sequestration than tidal wetlands. That may be a factor of the size of the data sets which have been available to us. And it may be that those two equilibrate, or they come closer together as more data comes online. It could be a factor also, it could be a reason of a number of factors. It could be that trees are just more productive. It could be a factor that as there's a latitudinal effect in there, and that as you move towards the tropics, productivity goes up, and that is playing in within the, of course, the mangroves are a tropical and subtropical species, group of species. But yes, so it could be any range of those factors. But the data sets as we have right now suggest a slightly higher amount of carbon sequestration by mangroves than the average tidal marsh.
Great, and I think we have time for one more question here. And so I want to come back to the IPCC. Are there gaps in the greenhouse gas accounting that the IPCC, which I'm not sure we actually ever said was International Panel on Climate Change, are there gaps that the IPCC is looking to fill?
Tiff, do you want to take this one?
Yeah, gaps trying to fill. Well, there's a constantly evolving process where panels of experts are taking in the most recent information to evaluate whether there is enough information to address some of the gaps that have been recognized. So it's not just about identifying gaps, but ensuring that there is sufficient global coverage in data in order to fill those gaps. I think there is there's some emergence of information that would allow gaps such as methane emissions from reservoirs to be addressed. And in fact, the IPCC is right now going through a process of identifying gaps fairly comprehensively, really across the set of guidelines that were issued in 2006, in addition to the supplementary guidance that came out in 2014, to try to do a sort of comprehensive gap assessment, as well as identify ways in which all of that guidance can come together in a slightly more streamlined fashion so that they're even more user-friendly across countries.
Great, thank you. I'm going to try and move us to the final slide that I need here, but as I'm doing that, we got one last question, which is carbon contained in animal biomass ever considered when calculating carbon sequestering values? Can one of you answer that?
I think the answer is no. We account for CO2, which is directly removed from the atmosphere in the plant material, and then is either stored in plant material biomass, living or dead, and soil carbon stocks. Whether it's included in animal material under the agricultural aspects of the inventory, I'm not sure, but certainly within our part of the inventory, under the AFOLU part, I don't believe that animal biomass in any way is included as part of this.
And the main reason for that, as I understand it, is that those are carbon pools, but they tend to be cycling a lot faster than soils or particularly plant material that gets incorporated into some kind of longer-term storage, like wood or into the soils, etc. So I think it's an issue of time scale to some degree. So, okay, with that, I know we're just over 2 o'clock, so I know we need to wrap up here. I just wanted to announce that our next webinar is April 27th. It's going to be by Richard Chin from Environmental Training Incorporated, and it's entitled The Clean Water Rule, Real Facts, which sounds very interesting. And so again, to all of you who aren't SWS members, if you would like to join SWS, this webinar will be available free as part of your member benefits. And to all of you SWS members, please tune in April 27th for The Clean Water Rule, Real Facts. Thanks to all of you for joining today, and thank you to both of our presenters for a great and fascinating webinar today.
Thank you very much.
Thank you.
It was a pleasure.
Indeed.